So now we will discuss about the chemical reactions. Okay, chemical reactions of carboxylic acids. In this video, we will discuss. On the very first basis, see what is the structure of carboxylic acid, that is R, C double bond O, O and H. Okay. In the first type of chemical reactions of carboxylic acid, we will study when O and H bond dissociates. When H positive releases the reaction which involves cleavage of OH bond. Okay. When there is happening cleavage of OH bond, RCOO, this OH bond is cleavage is happening. So those chemical reactions we have to study in this video. Okay. See, when this RCOOH, it reacts with the sodium. So H bond that will break, this H positive will release, okay, as hydrogen. Okay, H positive that will come from another Na. Okay, so this compound is telling us, this is denoting that this OH bond is breaking. Right now, the compounds which release H positive ions, they are acids, and carboxylic acid is that acid. Right, so which are strong acids? Strong acids are those which release their H positive release very easily. Okay, strong acids are those acids which release their H positive very easily and very fastly. Okay, now in this there is Ka. When this acid is dissociating, Ka is the acid dissociation constant. Okay, what is Ka? That is acid dissociation constant. And whenever we have to represent the strength of an acid, we represent this strength in form of pKa. That is, pKa is equal to negative log Ka. And here Ka is that acid dissociation constant. This Ka, that is acid dissociation constant, that is equal to K equilibrium H2O. Okay, which is equal to H3O positive RCOO negative upon RCOOH. Okay, this is related to somewhat equilibrium. This K equilibrium, this is representing that when the reactants concentration and products concentration is equal, at that time the constant is, that is equilibrium constant, and this Ka is equal to that. Okay, and to represent the acidity, we use another term, that is pKa, which is equal to negative log Ka. Okay, now understand this carefully. Ka is denoting the dissociation of acid. As I said, acid which will dissociate very fastly, okay, their Ka will be higher, right? And the acids which will dissociate late, they will not release their H positive, their Ka will be low. Okay, now if Ka is a high, Ka value is high. Now if it's minus log is there, right? So that means pKa value will be very less, right? And that means that acid is strong acid. When Ka, okay, Ka, that is acid dissociation constant, is high, then pKa value is less, means stronger is the acid. And when the value of Ka, acid dissociation constant, that is less, then pKa, okay, that is quite high, which denotes that acid is a weak acid. Okay, so this is very important. If pKa value is low, less, that means acid is strong, because Ka value is high. Because of this formula, this is negative log. Okay, Ka value is high, negative log will become, pKa value will be lower then. And here Ka value is less, then pKa value will be higher and acid will be weaker. Okay, Ka value is less because the acid dissociation constant is less, means that the H positive is not being released easily. Okay, so in this way we will discuss, we judge the acidity of an carboxylic acid. Along with that, one basic thing you always have to remember is that acidity is inversely proportional to electron density. Okay. Lower the electron density, higher is the acidity. And higher the electron density, lower is the acidity. Okay. If electron donating group is present, okay, electron donating group, any group which is having the plus I effect, electron donating group, right? For example, CH3. This CH3 group is there, okay, then it will, what will be happening? The CH3 group is there, right? They will increase the electron density. And if electron density will increase, the acidity will decrease. So electron donating groups, they decrease the acidity. Okay, they decrease acidity. And along with that, if an electron withdrawing group is present, which is having the minus I effect, for example, NO2, CN, cyanide group, nitro group, okay, they will extract the electrons and electron density that will decrease, and so acidity, it will increase. Okay, so these electron withdrawing groups, what do? They increase the acidity. Why? Because electron deficiency is created over there, electron density decreases. Okay, now we have to discuss some groups which are having their effect. So according to that, you have to learn that phenyl, iodine, bromine, chlorine, fluorine, cyanide, nitro, and CF3. Okay, in this order, this is the power of the some groups. Okay, that to what extent they can withdraw the electron from the carbon. Okay, so on the basis of that, acidity is decided. If in a group this is present, that will be having a higher density than this. If this is present, that will be having the lower acidity. So according to that, this is the order which you have to remember, and a very important question is asked from this part.